made me notice parallax of our trajectory looking out at Oriental. That and in the inner walls of the east side of the crater rings, you really get a sense that we're flying over something with elevation and terrain, and they look different from its orientation. You really get a sense.
Love to hear it, Victor, and you had it that those chains are actually crater rays, secondary craters formed from the formation of Oriental. Chains are actually crater rays, secondary craters formed from the formation of Oriental. Chains are actually crater rays, secondary craters formed from the formation of Oriental. Chains are actually crater rays, secondary craters formed from the formation of Oriental. Chains are actually crater rays, secondary craters formed from the formation of Oriental. Chains are actually crater rays, secondary craters formed from the formation of Oriental. Chains are actually crater rays, secondary craters formed
First 4 people to fly around the moon in over 50 years. This is our lunar flyby day, and the crew has already surpassed one record today. The crew passed the Apollo 13 hours. Checking in on the lunar targeting package, the crew is now in their discussion of the limb, seeing the limb of the moon, that illuminated part. Currently at the windows taking photos and making annotations are Victor Glover and Christina Cook. And we are expecting loss of signal in about 13 minutes. We will regain that signal with the crew about 40 minutes later. A milestone worth mentioning that this day marks the first time in more than 50 years that humans will observe the moon directly, a critical opportunity to practice how lunar science will be conducted during future Artemis missions. I've continued to reference the lunar targeting package throughout this broadcast, which is the primary tool guiding the crew observations, and that consists of 2 key components. The first of those is the Lunar Geography Review, which helped the astronauts study major lunar features in advance. That also helped them learn to orient themselves during the flyby. The Lunar Targeting Plan provides a detailed timeline of observation targets, background science context, and specific instructions for the picture the crew should take, and verbal descriptions of what will be helpful to the science team reviewing those pictures later. That's what we've been tracking real time and what the crew is using right now to keep up with their next milestones.
Integrity Houston, 10 minutes till the LOS. We'll take a snappy sit rep from the cabin if you have one.
Okay, Jenny, that came, we missed most of that, but just a 10-minute warning, is that what you're saying?
10-minute warning for the LOS, and I'll take a quick sit rep from the cabin, please.
All right, cabin is still full of excitement. We've got Christina in window 2, Ike in Victor in window 3. Reed's actually been trying to get some images out of the docking tunnel. We can see the Earth and the Moon and part of the Moon out of the docking tunnel, which is pretty good. And I'm just grabbing some footage right now with our interior cameras.
Copy, Jeremy. We'd like to know what camera Reed is using and also the status of window 1. Looks like there might be a shroud removed.
Okay. Reed was using the Z9, and the T-shirt shroud is still on window 1, but we took the camera out of it, so maybe that's what you're noticing. But when I looked in there, I saw a lot of sunlight reflecting around.
Copy. That makes a lot of sense to us, Jeremy. I want to remind you, coming up on this LOS, that we'll take sit reps in the blind, and as more and more of the moon is in darkness, we will take any report you have on impact flashes.
All right, Jenny, you'll have to say again your last. There's a lot of conversation here, and I was on the other side of the cabin, so I missed all of it.
Look out for impact flashes, and we'll take sit reps in the blind.
Okay, impact flashes, sit reps in the blind. We got it. And yeah, just so you understand what's going on with window 1, there is light coming through the outer hall from window 2 into the inside of window 1, if that makes sense. Like, I can see the inside of the vehicle when I look between the 2 panes of glass.
Copy.
You're getting your first live look at Orion, the Moon, and the Earth. Everyone in this picture. This is a live view from the Orion spacecraft. Currently aboard Orion, 4 crew members, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. And on the Earth, all of us, all of humanity. You can see the moon is starting to get a little bit dimmer as the astronauts are going to pass behind it. Now 6 minutes and 26 seconds away from that loss of signal. Again, we will be out of communication with them for about 40 minutes until they come around the other side of the moon and we can re-establish contact.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
Poignant words from NASA astronaut Victor Glover, and a little bit of a love letter from the other side of the moon all the way to Earth. Glover touching on the teachings of Jesus, including to love your neighbor as yourself. We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis 2 crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. Just about a minute and a half now until we lose communication with the astronauts aboard Orion on the Artemis 2 mission. Now 5 days and 6 minutes since their launch on April 1st. Again, we'll be out of communication for about 40 minutes. And this really beautiful view of a crescent moon and a crescent Earth. How great thou art. 30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. This is a live view inside the Science Evaluation Room here at Johnson Space Center and just down the hall from Mission Control. This team has been monitoring the flyby all day as the team has continued capturing targets on the lunar surface. We even got to see this team in action as they were helping the astronauts identify some of the features they were seeing on the moon but not expecting. There will be a couple of milestones during this loss of signal. The first will be when the astronauts make their 5 days, 25 minutes, and 34 seconds, when we expect they'll be 4,067 statute miles above the lunar surface. Their maximum Earth altitude will be reached just 2 minutes later, at 5 days, 27 minutes, and 39 seconds, when their altitude should be approximately 252,756 statute miles. Once those milestones are reached and we have confirmation, we will report the official numbers. Throughout the Artemis II mission, thousands of miles carried on signals from NASA's powerful communications systems, the Near Space Network and the Deep Space Network. Let's learn a little bit more.
NASA's Artemis II will send 4 astronauts around the moon, preparing humanity for a long-term lunar presence and future journeys to Mars. Enabling communication and navigation for this test flight are NASA's Near Space Network and Deep Space Network. With antennas around the world and a fleet of relay satellites, the networks will deliver vital data to and from Earth through all phases of the mission. The networks are seamlessly integrated at NASA's Johnson Space Center in Houston, Texas, where Mission Control coordinates the network handovers. These transfers represent a delicate dance between the two networks, exchanging support as the mission shoots toward the moon. On the launch pad and during their early orbit phases, NASA's Orion spacecraft and Space Launch System rocket will rely on communications and tracking services from the Near Space Network. After its translunar injection burn, the Deep Space Network's global array of antennas will serve as Orion's primary communication support during lunar orbit. As the mission journeys farther into space and away from Earth, signal strength weakens and bandwidth is conserved for crew communications. The astronauts will have a near constant connection to Earth, ensuring their safety on a journey farther into space than ever before. We say near constant because as Orion goes behind the moon, a planned loss in communications will occur. The Deep Space Network will be standing by to reacquire the signal as Orion reappears. The Artemis II mission also provides an opportunity to test new capabilities. Using laser links, NASA will periodically transmit Orion data to showcase the benefits laser communications could have for future human spaceflight missions. The data from Orion, sent by radio signals or laser links, is massive. The mission is gathering images, data, and video, while also generating details about mission health and crew voice files. All of that data gets processed here on Earth, where systems compress it for efficiency. In the future, we'll upgrade these systems on Earth so that image and video clarity improve with each moon mission. With the Artemis II test flight, we're evaluating the communications infrastructure that will help carry us into the future as we explore the moon and journey forward to Mars.
We are now about 33 minutes until we expect to regain communications with the astronauts aboard Orion. And in the meantime, I've got Dr. Kelsey Young, Artemis Science Flight Operations Lead, here with us. Thanks for joining me, Kelsey.
Thanks for having me. This is such an exciting day.
Oh, no kidding. It has been so cool to hear you communicating directly with the crew. And I know that you have been preparing for this for years, so I am so excited for you and for your team. So just to get into that background a little bit, tell me about your background and what you've been doing on console.
My background is as a field geologist. Actually, I studied impact cratering in the field for my PhD, so all these descriptions of impact craters have me just absolutely swooning. How I got into this, though, is, during my PhD, I got an internship at NASA and ultimately never left to integrate science into flight operations. So we developed the Science Officer Console, for which this is the first mission we're supporting. We developed the Science Evaluation Room that's right upstairs, and so it's so gratifying to see this operation structure come to fruition, especially on a day like today.
I would have to imagine so. And we've got a great view of the Science Evaluation Room right now. Is there anything that has stood out to your team so far?
Absolutely. So as you might have heard in some of the press briefings and content that, we've been putting out, color and albedo were really exciting targets for us. We've heard several amazing color descriptions so far. Just to highlight maybe one of them, we heard about greenish and brownish hues near Aristarchus, which is actually a feature that we can see here from the near side. And those greenish hues could actually tell us something about the volcanic evolution of that area. So you can bet that the science team is going to be prioritizing downlinking those images and the crew audio that we didn't hear that went into those recordings to learn a little bit more.
Wow, that is fascinating. I was hearing those colors and very interested just from a personal standpoint, because looking at the moon from, 250,000 miles away, we don't see green or brown. So just hearing that, them being so close and getting to see that, fascinating, and I know very exciting for you. So what are you expecting to see in the upcoming portion of the flyby?
The upcoming portion is actually going to be really exciting. So right now, as we speak, while folks in the room are kind of taking their, their stretch breaks and everything, the crew are still hard at work. They still have targets to image and describe during this LOS. But when we come out, the first thing, of course, we're going to hear about is Earthrise. We're really looking forward to hearing about the crew's experience with something that we can connect with and that, Apollo 8 brought us such amazing images from. But then we start to get into describing the Terminator as well as looking for things like lofted dust, which tell us about the modern lunar environment. Then the vehicle's going to orient away from the moon for an hour and then pivot back for the eclipse observations, which is a whole different set of science observations that we're really looking forward to.
It's kind of nice that the crew will get a little break in there because they have been hitting it hard today with photos and videos and annotations. What are you hoping that the crew sees coming up? Is it that lunar dust?
Oh my goodness, that's a hard question to answer. I mean, we've already gotten such great descriptions. I mean, the Terminator seems to just be like one of their favorite things to look at and describe. So I feel like, that was something we were looking forward to. I feel like we've really gotten some great descriptions. So absolutely, I'm looking to the human moment of Earthrise. Lofted dust is an exciting one, and lofted dust will be a target for them in the right around the time of Earthrise, but again in the eclipse period. So I'm really looking forward to seeing. I mean, they've already highlighted just in the course of their flyby so far how the moon has changed, and this is going to be even more dramatic change to go from their end of this kind of lunar illuminated piece of the flyby into the eclipse time frame. And I can tell you they're going to be experiencing a very different moon during that time, and I can't wait to hear what their observations are.
Yeah, that's absolutely fascinating, and what an privilege that we get to do that on this mission, because that's not always the case. If we had launched on a different day other than April 1st or 2nd, we wouldn't have gotten to see that eclipse. Is that right?
That's correct. April 1st and 2nd. I will say, I was asked a lot in the weeks leading up to the launch, well, what's your favorite day? And my answer truly was there is no bad day to launch to the moon. We were going to get great science out of it no matter what, but it's a really neat opportunity to, bring the sun into the picture, bring different planetary bodies into the picture while still literally keeping the moon in center stage.
Fascinating. So what differences are we looking for at each site? We're hearing a lot of different terms. We're looking at craters. We're looking at mare. What are the differences that you're hoping to see?
We do have, as you highlight, kind of different prompts for each target. That's what they're looking at in their lunar targeting plan, which I know you've been showing. And we have even different prompts for the person with the really long lens on the camera versus the people with the unaided eye. And you've heard the crew talk about, oh my goodness, when I go from one to the other, I can really detect different nuances. And that's something that we experienced in simulations, but hearing them actually, see it for real has been really gratifying. But we're looking for different things based on the target. Sometimes we're looking for color. Sometimes we're looking for texture. For the Terminator, we're looking at kind of what texture and morphologies pop out to you and what kind of diversity you see along the Terminator. You've heard, Victor especially make some comments about future impacts for exploration. So already I think that their descriptions in this first part of the flyby have told us something scientifically, but also about future surface missions.
Well, it was so interesting to hear Victor talking about he was imagining in his mind's eye being down on the surface and walking around. That was very cool to hear. And when we're thinking about targets, I know some of them are determined based on the launch day because that determines the lunar illumination. So the ones that we're looking at today, how and why were these selected?
Such a wonderful question. This really gets at at the heart of some of our really highest priority science questions. Illumination conditions is a big one, right? So of course we need the targets that we're interested on the lunar feature to be illuminated by the sun in order to view them, but the timing in which they see them during the flyby enables us to ask different questions. So you heard in the pre-flyby crew conference talking about, well, the same pair, Reed and Jeremy, will get to actually look at Glushko crater twice, and that looking at it from different illumination angles allows us to understand that feature better and connect color and albedo with topography and morphology. Then you have other craters where you want to look at it with the sun shining on it obliquely versus straight on, and that tells you something different about the scientific objective that drove the target being on the targeting plan in the first place.
We've talked a little bit with the viewers today about what the crew is able to capture in this short time frame of those craters in different lighting conditions. Could take years for something robotic to be able to do based on attitude maneuvers and where the sun is at. So can you just talk a little bit about the importance of having both the robotic operation and having the crew?
Absolutely. We definitely don't want to minimize the impact of orbiting spacecraft. Lunar Reconnaissance Orbiter is the one that's often referenced. Data from LRO and its payloads have really been instrumental in getting us, frankly, to this point for Artemis 2 and future missions. But the human experience, the crew observations that we've already been hearing about, it is such a perfect complement to the orbiting spacecraft data because they are able to have this unique perspective. They are far enough away where they can make these contextual observations. You've already heard it. How many times have we heard the crew and their science sit reps say, if I track this feature from all the way up here in the northern hemisphere down to the southern hemisphere, here are comparisons I can make. That right there is not something we had the ability to do with the Apollo missions, and it allows just literally in the blink of an eye to synthesize observations that it would take, a really significant effort to coordinate with different orbiting platforms, and they're making it like that.
Wow. It has been very, very exciting to hear all of their calls so far. And so I've heard they were able to capture every single target so far too. Is that correct?
I think that's correct. And I think it's important also to remember that, and I know the science team is anxiously awaiting this, we've been hearing from the crew members who are not at the forward windows, right? Those crew who are, really in the thick of the observations, they are recording minutes-long observations per target on their crew tablets. We will be getting those down starting here in a couple hours, and that's going to contain really meaty science information that we haven't heard live yet, and that's going to form the basis of my conversation with them tomorrow morning, where we're going to have a really deep dive into the science and absolutely nerd out about what they were able to do today. One of the most gratifying things for me today is hearing multiple crew members say, thank you for putting the discussion times in the targeting plan, because when we have had the ability to put multiple brains on a problem, we have elevated each other. And I'm looking forward to them, sleeping on it overnight and then us actually being able to really, truly have an elevated science discourse tomorrow.
Well, we're looking forward to it too. And I cannot wait to hear everything that you guys get to learn overnight from some of those audio recordings and just everything that they'll be able to share tomorrow. So Kelsey, I know you are very busy. You've done a great job today. And thank you so much for joining us for this interview.
Thanks for having me. It's such an exciting day.
We are now expecting acquisition of signal in about 24 minutes. As a reminder, the Orion spacecraft has flown around the other side of the moon, where they are out of contact with our deep space network. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds. And we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the Earth, of the moon, the Earth now out of sight. What they're in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with integrity and the astronauts for Artemis 2. We're live in Mission Control Houston at NASA's Johnson Space Center, but there's a team over 750 miles away also monitoring today's operations. And of course, just like us, they are in LOS, or loss of signal, with the spacecraft. This is LUCA, the Lunar Utilization Control Area, and it's joined by LISA, the Lander Engineering Support Area, which are twin control rooms that will support missions and operations in lunar orbit or on the moon's surface in real time at NASA's Marshall Space Flight Center in Huntsville, Alabama. The LUCA and LISA are right next to each other and just a short walk away from the SLS Engineering Support Center, which is used during launch, and the POIC, where science on the International Space Station is monitored. LUCA primarily supports Artemis science operations, while LISA will provide engineering support for landing astronauts on the moon. During this mission, Artemis 2, teams in the LUCA will use the facility to support first-of-its-kind science operations to better understand the deep space effects of microgravity and radiation on the crew's physiology, immune systems, and ability to complete various tasks. The data from these science operations will inform future crewed flights to the moon. For future crewed missions to the moon, members of the NASA Human Landing System Mission Insights Support Team, a group of engineers, safety leads, flight operations experts, and technical authorities, will work in the LISA. There, they will monitor lander systems in real time and be involved in key decision-making processes throughout the mission. Teams are using the LISA during Artemis 2 to observe mission operations and using the opportunity to inform and prepare for future crewed landings to the moon's surface. We now expect to regain communications with the astronauts aboard Orion in about 17 minutes. In the meantime, a little overview of how our crew members flying by the lunar far side at an altitude of between 4,000 and 9,000 miles are testing the capabilities of the Orion capsule. Artemis 2 visualization lead Ernie Wright has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The Artemis 2 crew members have been using these visualizations to prepare for this historic mission, which is paving the way for future exploration of the moon's surface and beyond.
So the most exciting thing to me about Artemis 2 is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis 2 will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close, and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Oriental. Oriental is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Oriental has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than the near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission.
This live view in the Science Evaluation Room, or the SIR, here at Johnson Space Center in Houston, Texas, just down the hall from where we're at in the Artemis Mission Control Room. Teams continuing to monitor the flyby. The crew continues their observations of the moon, even though they are out of touch with Earth. We expect to hear from them in 12 minutes and 26 seconds. Again, this is approximately 40 minutes loss of signal while they are out of reach of the Deep Space Network. Right now, they are imaging or attempting to image lofted lunar dust. Throughout our coverage, we've talked a lot about the science and engineering behind today's lunar flyby, but we also spoke to the crew about what the moon means to them and how they see its place in human history.
I remember being a little kid lying in bed at night and just looking out at the moon in whatever phase it was in, and I was thinking, man, my friends that live like 20 miles away, they can probably look out and see that same exact moon. And then when I was in the Navy and I would look out at the moon and I'd be halfway around the planet, and I would think, man, my brother can see that moon where he is, and he's halfway around the planet from where I am. And it's a connection of life on Earth. We can all look up and see that moon.
It represents history. It is a witness plate. Everything that's ever happened to the moon is still written on the moon. There's no processes of wind or change in the Earth, geologic processes like we have here that change it. And something that's been telling and can read out the story of its own evolution, there's something beautiful about that.
I've also learned from my indigenous mentors that they refer to the moon as Grandmother Moon. So you've probably heard of Mother Earth. They use Grandmother Moon because Grandmother Moon is responsible for the water in their community. The grandmothers, sort of protect the water source, just like the moon moves the water around the planet, affects the tides. It's something that represents something different for each individual culture around the planet. And that's really neat because we all share that same moon in the night sky.
We all have seen the same side of the moon in different lighting conditions our whole lives. And so it seems very familiar to us, but it's also kind of unknown. When we get up close, some of the imagery that we'll get to describe and to share with people will be very unique. And that nature, both of those things being true about this one entity that we all know, just is really special.
It's just the epitome of a symbol of both something that's in each of our hearts, but that's also represents exploration and reaching.
You're looking at a live view inside Artemis Mission Control here at Johnson Space Center in Houston, Texas. We are currently out of contact with the Artemis II crew. This was a planned, or not really a planned, but a tracked loss of signal that occurs when the crew flies behind the moon. We use the Deep Space Network to communicate with the crew, and when they are behind the moon, they are out of reach of that Deep Space Network. And when you consider our nonstop communications during the time in which we live, this is even more striking. For the Artemis II crew, they're only currently communicating with each other. Now, we expect to regain those communications in under 9 minutes from now, and we also are hopeful for a view of Earthrise. Despite being out of communication, the crew is continuously capturing imagery of their predetermined lunar targets. Now about 7 minutes, 25 seconds until we anticipate regaining communications with the Artemis II crew aboard Orion. In the meantime, Artemis II lunar science deputy lead Marie Henderson is trained these astronauts to capture and document their views of the lunar surface for all of us to enjoy back here on Earth.
I cannot wait to hear their voices when they get to the far side of the moon and I can hear them talk about seeing the moon out their window. I try to imagine it now and just like tear up thinking about it. Ooh, now I gotta hold on a second. We have human eyeballs connected to wonderfully smart brains our astronaut friends have. They are going to be able to observe the moon in multiple different ways. They can use their eyes, they'll look through their camera and snap pictures, and just looking out the window getting that human experience. But during Apollo, the astronauts were so much closer to the lunar surface. Our astronauts are going to be doing a flyby at a higher altitude, so they're going to be able to see the whole moon as a lunar disk on the lunar far side. That's a brand new, unique perspective that humans haven't been able to look at before. We are doing a lot of lunar geography training with them. They have study sessions and quizzes they can do that are assigned to them. You know, even if you're an astronaut, you still get homework. We actually get in the mock-up. In that enclosed physical space, we have to think through the hardware that they have, the cameras, the computers, their microphones to make these observations. There's 4 windows up front. Through one of those windows, one of our astronauts will be using a Nikon D5 camera with an 80 to 400 millimeter lens. So something that allows them to zoom in really far and actually take more detailed observations of the surface. It's almost like looking through a pair of binoculars as well. It's just like being a geologist out in the field. They're telling us what they're seeing, looking for colors, textures, different morphologies, and comparing the region that we're having them look at to the regions that are around them. We have a science team that is planning the targets that are going to be observed, putting them all on the timeline of how they're going to be observed, and then taking the first look at the data when it comes down. The Apollo astronauts were only on the moon for 300 hours total, and they only went to the equator. That's like going to places that were safer landing sites, and they only saw so little, 300 hours total. And so we have so much more to explore and so much more to learn, and we are the beginning of the next generation that gets to start being a part of these discoveries.
We are now 4 minutes and 28 seconds until we expect to regain communications with the astronauts flying aboard Orion on the Artemis 2 mission. They are now flying behind the moon. While behind the moon at an MET, or mission elapsed time, of 5 days, 25 minutes, and 34 seconds, we expect this was the point in which they made their closest approach, 4,067 statute miles above the lunar surface. We're live in the Artemis Mission Control Room in Houston, but we are not the only room monitoring today's flyby. As you can see, this is the SIR, the Science Evaluation Room. It's in the same building and just down the hall. It's a multidisciplinary science team supporting the Artemis 2 crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. You can see the SIR here. That's the Science Evaluation Room. It's embedded within Mission Control to provide science input during live operations like what we see today. But additionally, the Science Mission Operations Room is a back room that processes data, evaluates imagery, and supports rapid analysis. We also have our science officer, Kelsey Young, here on console today. She's serving as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Coming up on 1 minute and 36 seconds until we contact Orion. Meanwhile, aboard the spacecraft, the crew has continued executing their lunar flyby tasks. As we discussed earlier today, these activities have been precisely timelined, and this is the fourth of 5 blocks of time during which the crew will be observing the moon from Orion's windows. At this time, pilot Victor Glover and mission specialist Christina Cook are observing the moon at windows 2 and 3. One crew member is in window 2 with a blue shroud over the window, taking photos and using an 80 to 400 millimeter zoom lens, while the other astronaut is in window 3 using their portable computing device, also known as a PCD, to make annotations. And both of those crew members are making audio recordings of what they are seeing. They are wearing headsets connected to their PCDs, and those audio recordings are being sent to the science team tonight. We are not hearing those live. However, we have been hearing quite a lot of great descriptions from the crew who have been serving as the support. Right now, the support team members are Reed Wiseman and Jeremy Hansen. Those team members are providing science sit reps, situation reports, calling down a few times each hour to discuss what they're observing. And even though we're out of contact with them right now, they are still conducting those science sit reps as they'll be available once they come back around the moon. The situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw. They're also including lunar target descriptions, any hardware issues, and their emotions and reactions.
Dona Rejane, boa tarde, tudo bem com a senhora? Dona Rejane, a senhora conversou com seu esposo referente ao contrato de locação? Eu preciso fazer o novo contrato com a atual proprietária, né? Eu precisava saber se a senhora vai ficar só até setembro ou a senhora vai querer ficar por mais um ano, né? Que a gente faz o contrato direto, mantendo o mesmo valor, tá bom? Me dê um retorno assim que a senhora puder. Obrigado.
We're in the Artemis Mission Control Room at Johnson Space Center, getting our preliminary contact with Orion, that acquisition of signal coming after a 40-minute loss of signal, during which the crew was flying behind the moon, out of contact with anyone on Earth. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. Right now, the crew are getting a few moments to enjoy and take photos of Earthrise for themselves, and we expect to contact them shortly. But we do have good signal coming from Orion. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by
integrity. Comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back.
We are happy to say we copy.
Those first communications back with the astronauts aboard Orion. Christina Cook calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour, and it's probably a welcomed break following their very, very busy day taking pictures, making also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Because of that eclipse, Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization. The spacecraft now 4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home. Again, we are MET, mission elapsed time, 5 days and 58 minutes since the launch of Artemis 2. We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis 2 patches around. We are earthbound and ready to bring you home.
That's great. Great to see the light of day as we head back to
A very special moment just now in mission control ahead of the crew's flight to Kennedy Space Center, and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, The flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew. And the Capcom, Jenny Gibbons, did call that update up to the crew that the flight control team here has turned their patches around, as was instructed by the crew during that last sim. And we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission. Joining me here in the room, Artemis Mission Control, I have Angela Garcia, Artemis II Science Officer. Thanks for being here, Angela.
It is an honor to be here. What a day. Everyone's been buzzing. I can't contain myself. So it's been a really awesome day.
So you're sitting on console at the Science Console now. Have you been in the SIR earlier today?
There's a lot going on. So I went here first, and then I'm going to go there after.
All right, Integrity, we hear you. That was a little clipped, but I think we have a better link now. We experienced some blockage from a solar array. We moved it, and we are in bias, tail to sun.
Okay, Houston, you're coming in loud and clear, and copy, we're in bias, tail to sun now.
Affirm and Integrity, just so you know, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back.
Okay, copy that. We were just excited that we got to share in that you, the MER, and Mission Control have flipped your patches around, and that side of the patch is getting to see the light of day. Thanks for sharing that with us.
Our pleasure.
Okay, Angela, so can you tell me a little bit about your role supporting Artemis II and the science preparation for the mission?
Yes, so I'm one of the 3 science officers. So Kelsey's been on console all day. I'll take over kind of closer to the end of the day, and then Trevor Graff is on the planning shift. And so it's the 3 of us in this 24-hour cycle supporting the mission. And so the science officer console is a brand new console to mission control. And it's not every day that you get a new discipline incorporated into mission control, so it's been such a significant milestone for us. And it's just a testament to the commitment Flight Operations Directorate and NASA have, that they're going to be integrating science and maximizing science throughout Artemis. So it's really exciting. And then the science preparation, So I'm on the operations team, but I'm also on the training team. So all the incredible training and shout-outs that you've gotten today, it warms my heart. It warms everybody's heart in the science evaluation worm. I promise you that. But so all the classroom training, the field training, the mission simulations, right? We were part of all of it, and that is what we did to get the crew to be. They are a part of the science team, and they are the forefront, that nice edge, and they're just been doing such a great job today.
I know. I imagine that you have to be pretty proud of them. Their reports have been fantastic. So I would like to know a little bit about how you have developed procedures for this crew. What kind of science activities are they carrying out inside the spacecraft?
Yeah, so the procedure development has been a unique challenge. I'd say the exploration science that we're doing is inherently pretty flexible, and operations is, I'd say, inherently has more structure and rigidity. And so to marry the two and to operationalize the science that we want to get done has been a challenge. But I think we've been able to go through these processes and create good products at the end and have a good plan. And yeah, it's been really great. What was the second part of your question?
Just what kind of these science activities that they're performing, which of those are really
a lot of the procedures help organize what the crew is doing in the cabin. And I know we've talked a lot about, what they've been doing, and they've been doing a lot, and it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized, the 4 crew members are organized into 2 pairs of 2, the window team and the cabin team. And the lunar targeting package that you've been showing up and that the crew have on their handheld tablets is really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens. One has, they're just looking out the window with their unaided eye, and they're taking these detailed observations. And then halfway in that observation block, they do the window team position swap. So that's what Capcom's been calling out, and they'll switch positions. So each crew member has a chance to have that long lens. And then that's just what the window team is doing. There's also the cabin team, where they also have duties that they're doing. We're asking a lot of the crew in this time. And then the cabin team, they have the interior camera, and they're taking images inside the cabin. They're also supporting the window team, where, you've heard some call-outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot, and so making sure we have a plan that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure development, right, you have so many different environments that you can do. You have classroom, like we said, you have the Orion mock-up, you have simulations, and at least for developing the plan, we kind of did it in a tiered approach, because each of those different analog environments helps us answer a slightly different question and has a little bit of a higher fidelity. So we would start with the classroom. So we would we would just get into a classroom, we would put all the hardware on the table, and then we'd almost role play of like, you be Victor, you be Reed, you be Jeremy, and I'll be Christina, and like, let's just do the plan how we think we should do it. Write that down, and then just keep iterating on that, and then
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first 2 are for timeline. First of all, Reed for your toilet maintenance. It is a shortened toilet maintenance where you do not have to do the aux zone changeout. That portion of the procedure is canceled. Victor, you have an HHP stop activity on your timeline, we need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the eclipse, we want to remind you that you can take off the eclipse glasses when the sun sets and you are simply looking at the corona. And then finally, for the D5 with the long or zoom lens, which is set for solar corona, we want to remind you that when you are capturing Earth shine, you will likely have to adjust the exposure. That's all I have for you. Let me know if you have anything for us.
Okay, Houston, we copy y'all. Thanks for those words, Sydney.
All right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So, Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reed. Tell me more about this.
Yeah, it works pretty well. So you're going to do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it. And then they'll be like, these steps don't make sense. And we'll reiterate on it over and over. And then we'll take it to a higher fidelity environment like the Orion mock-up, and we'll do the same thing because that volume is smaller, the window placement, their seating, what things have we forgotten with this addition of this environment. And then once we reiterate on that, we'll take it then, we'll give it to the crew and have them execute off of it during mission simulations. That's the highest fidelity that we can do before we send it to space. So this is the first time we've had to do this because we're a brand new console, and it just sparks so many neurons of like, how are we going to do this for surface missions and integrate this in so many different ways. So excited to have kicked off this process, but there's so much more to come.
Fascinating. And I think it was really well thought out too, because each crew member gets an opportunity to do each task. And so you're getting different perspectives and different insights from each crew member, maybe even about the same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis 2 has traveled. They're now on their way home, but they traveled farther from the moon than the Apollo missions did. So what makes that vantage point scientifically interesting?
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques. And so for this, so we really tried to make the plan to optimize those. There's pros and cons for all those things for this mission. So we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things. This different perspectives. So their perspective, as Kelsey talked about, photometry around when they orbit the moon. And then also just their different the different things they're able to observe. So yeah, let me talk a little bit about scale, because I think observations at different scales, you can gain a lot of different information. So like, for example, if you were an astronaut on the surface looking at a rock, and you describe at this micro scale. So in training, we kind of talk about observations from micro to macro, or from outcrop to orbit. So looking at a rock at this scale, you can describe its components, you can describe what it's made of and its colors and its minerals, and you're like, okay, and this rock came from this boulder, and it's this part of this boulder, and these are the different things that I'm observing around. It gives me context to this sample, and then you zoom out a little bit more, and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge, or this high ridge feature. And then because I can see the trail that it came from, okay, now let me describe this ridge and different parts in it, and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale, and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information, and so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar. On Earth, we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it, all at the same time, which enables the astronauts to compare very quickly to different parts of the surface. And the color particularly is very compelling because you can just be able to very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. So one last question. We are coming up on the last lunar flyby observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah, so the data set. So yes, there's so many things. How to pick one. So I'd say the thing that I'm most interested in seeing is some of their annotations that they're taking. So in this opportunity, it's a very dynamic type of experience in that we don't normally see this activity. And so being able to have crew observe the solar corona and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments, and so personally, I'm really excited to see some of these annotations and to see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. But if you're drawing and you're marking, particularly just going back to like the color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's been some famous annotations that the Apollo crew have made, particularly about solar coronas and the structures that have, and lofted dust that have given a lot of debate within the scientific community of they're observing this phenomenon, and now it's our job to hypothesize of like why are they observing this, like what is going on. So I think that's just a really cool part of exploration and science, and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotations too. I mean, I've been excited about the pictures and the audio, but now
don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw out, and we have pictures that they can just draw right on. It's like this particular thing is different than what we've seen, so I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on Console.
Thank you, and you've been doing a great job, and it's so excited to see where we go from here.
Thank you so much. Integrity Houston, you have 3 minutes until we go into a forward link LOS.
We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
We're live in Artemis Mission Control at Johnson Space Center in Houston, Texas. This a live view from the Orion spacecraft with our Artemis II crew inside. That's Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. We are still live for our lunar flyby coverage. The crew is in a short break while the spacecraft is pivoted away from the moon. We are going to be going into a solar eclipse. This is the first time anyone has ever seen a solar eclipse from the moon. So it's going to be a unique vantage point for our crew. But ahead of heading into that solar eclipse, we need to charge the batteries on the Orion spacecraft. Therefore, we have positioned the solar arrays into the sunlight to allow time for those batteries to charge. We will get back pointed at the moon just in time for that solar eclipse. We are also in a forward link LOS. What that means is essentially we cannot send calls or commands to the crew right now from the ground. However, we clearly get all of their data and communications. The spacecraft is now 4,632 miles away from the moon, and that number will only continue to grow as the distance from Earth shrinks, now 252,523 miles away. Our closest approach to the moon today was approximately 4,067 statute miles in altitude. Our maximum distance from the Earth is suspected to be 252,756 statute miles. Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track-Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity, now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timeline test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis II. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage. Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before eclipse. The crew is in a little break during our flyby coverage for today. They will resume their flyby momentarily in about 30 minutes once they get into their observations during that solar eclipse. Now, the moon is our nearest celestial neighbor, orbiting Earth at less than 250,000 miles on average. When our astronauts venture there for future Artemis missions, they'll target landing sites near the lunar South Pole. There, ancient rocks, minerals, and trapped water ice will not only provide resources for human explorers, but they may also contain clues to the formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily become untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.
You're looking at a live view aboard the Orion spacecraft of the Artemis II crew, working in the middle of one of their breaks, or really their only break today, during this lunar flyby period. Coming up next will be that solar eclipse. Throughout the Artemis II mission, and of course throughout today, you've likely heard the crew being called with the name Integrity. The Artemis II crew members named their Orion spacecraft Integrity during a news conference September 24th, 2025. The name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. They said this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. The crew also said that integrity is rooted in a shared core value of NASA, the agency's astronaut office, and the CSA, the Canadian Space Agency. We are 5 days, 1 hour, and 38 minutes mission elapsed time into Artemis 2. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so at NASA, and for this mission specifically, at NASA Artemis. Again, we are in a forward link LOS, or forward link loss of signal with the crew, meaning that we're not able to communicate or send any commands to them right now as they were. This is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Houston integrity in the blind. High priority PAO activities on Reed's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
This is Artemis Mission Control. You heard Reed Wiseman, commander of the Artemis II mission aboard Orion, make a call in the blind. This means he knows we cannot call back and that he knows we may not receive his call. However, we have good communications with the spacecraft. They just cannot hear from us right now due to a forward link loss of signal. Again, we were tracking that this would occur, and we will regain that momentarily. But that call that came down from Wiseman mentioned some imagery, so we are very much looking forward to getting pictures taken from the moon today. Again, to see those images, make sure you follow NASA on our social media at NASA and at NASA Artemis. The view on your screen right now is an animation. This is called Arrow, or Artemis Real-Time Orbit website. You can visit this for yourself at nasa.gov/trackartemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes. This is Artemis Mission Control. We are in a forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles. We are still in our lunar flyby coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so. Something that we also have to consider when it comes to our missions and launches is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
This is a live view from the Orion spacecraft on the Artemis 2 mission. It's now been 5 days, 1 hour, and 54 minutes since we launched. We are still in our flyby coverage, and the crew is on a short break right now as we have changed the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now, we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. We're interested to learn if they see the outer corona when the sun is fully obscured by the moon. And because of how big the moon will be from their perspective, the total phase of the eclipse will last nearly an hour. The astronauts will see a partial solar eclipse as the moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion. The astronauts will also be using cameras to capture images of the corona during the eclipse. There also may be some other planets visible during the eclipse, including Venus, Saturn, Mars, and Mercury. If they can identify what part of the sky they're looking at, this can help train future Artemis astronauts on what part of the sky they're seeing. This provides useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. Confirmation from teams here in the ground that we have reached the eclipse attitude, meaning Orion is in the proper position to observe it. The astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts. You're getting a live look from Orion as the crew observes a solar eclipse from the moon. Again, this solar eclipse is only visible to the crew on the spacecraft. It's not visible to anybody on Earth. The science team is interested in several different targets for them during this time frame. And we're personally looking forward to getting those images as well. Again, during the beginning portion of this eclipse, the astronauts will need to use eclipse glasses, just like we do from Earth, to safely view it. Once the moon has completely covered the sun, they'll be able to take off those glasses for almost an hour. Totality on Earth during a solar eclipse lasts only a couple of minutes. So this opportunity gives them a chance to look out into deep space and to look into see if there are other planets nearby. What you're seeing right now is the solar corona. That's the outer atmosphere of the sun. And the science team is very interested in any images that the crew can capture of this. They're hoping that they'll take pictures and describe the visibility, color, and shape of the solar corona as a whole and its substructures, those plumes and streamers.
Science, integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon, you could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reed is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing.
Again, you're looking at a live view from the Orion spacecraft on the Artemis II mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis Mission Control Room in Houston, Texas, and what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of the lunar flyby. We're now over 5,500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. And teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft. You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely. It has been an absolute honor to join you here today for the lunar flyby of Artemis II, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
game is shifting around in the windows, and we are transferring settings on a camera to pick up Earth shine, and it is amazing. The brightness where the corona, where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
You know our rules that we don't talk when the crew is talking, so wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering the sun. A really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the Orbit 2 team comes to join us. So thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So as you mentioned, the Orbit 2 team of flight controllers is currently making their way on console and completing a shift handover with the Orbit 1 team of flight controllers. The Orbit 2 team tonight will be led by Flight Director Diane Daly, and she is currently handing over with the Orbit 1 flight director there on your screen, who was Flight Director Jeff Radigan. The Artemis II crew currently on board the Orion spacecraft. It continues to observe the eclipse that they are witnessing. There's about 43 minutes remaining in that eclipse period. This is Artemis Mission Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
integrity. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
This is Artemis Mission Control. You were just hearing some communications called down from NASA astronaut Victor Glover, currently on board the Orion spacecraft. They are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period. Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
He's seen 2 meteors, science.
So we are in a forward link loss of signal. We do expect to regain signal in about 3 minutes, and at that point then the ground can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond, so they are continuing to provide some science observations during this eclipse period. They've made some comments about Earthshine, which is the sunlight reflected from Earth when they come around towards the moon's near side late in this flyby window.
Science, integrity, and the blind. The glow around the moon is beginning to become a little bit more even. It's not so much distinct just where the sun set on the moon's horizon as we're flying through this trajectory, and then the sun's going to come up out of the other side. I think it's we're starting to see the glow around the moon get balanced out. I still see Earth shine, and the Earth is very bright out there. Still quite an unreal sight.
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey Jenny, we have you loud and clear, thanks.
Copy. Victor, we're handing you over to Science for some critical questions. Thanks for your report.
Integrity Science, we were loving your science sit reps in the blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reed observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
Os 4, 2Z, se quiser digitar o mesmo código hexadecimal, mas não tem um certo ou errado, você colocou na parte de baixo. Outra coisa que a gente pode fazer, eu quero deixar mais enaltecido, clica o botão direito do mouse, aqui também você consegue aumentar, enfim, e a dureza eu vou deixar em 0% para ele ficar mais suave também, as bordinhas. E aqui você pode vir criar uma vinheta, como você preferir aqui na sua imagem também. Apenas para dar maior destaque para a parte do centro da nossa imagem. E inclusive vou arrastar essa vinheta para cima do splash do chocolate aqui também, ó. Tudo isso para que não fique tão nítido os cantos da nossa imagem, a gente atrás e pode dar um OK. Manualmente, você também pode colocar um laranja, algo mais intenso, ó, para dar um destaque aqui na parte de cima, né? Então, um tom que eu tinha escolhido aqui em off, que eu curti bastante, é quase próximo a esse que eu acabei de colocar aqui. É o F6 9C 54. Tom de laranja bem próximo àquele que eu tinha escolhido. Dá um OK novamente. E agora eu vou escolher o estilo radial, para deixar ele aqui do centro. Tom de laranja bem próximo àquele. Um tom que eu tinha aparente, clico e arrasto para baixo para deletar a última cor, e eu só quero essa cor primária aqui mesmo. E é aqui que eu vou colocar um laranja, algo mais intenso, ó, para dar um destaque aqui na parte de cima, né? Nada de tons ali com o fundo, né, com o chocolate que a gente colocou na parte do 2Z, se quiser digitar então, de como se a xícara estivesse por detrás lá do splash de chocolate. Então veja como é que estava e como é que ficou. Legal? Outros preparos que a gente já pode ir colocando, por exemplo, uma cor de fundo. Então podemos vir aqui em plano de fundo para colocar já uma nova cor sólida e deixar ficar embaixo das camadas. Então ajuste cor sólida. Aqui você pode buscar uma tonalidade que se encaixe legal. Você pode vir inclusive com conta-gotas e buscar algum subtom aqui da sua própria imagem. Ó, esse aqui já ficou interessante. Então 47342Z, se quiser digitar o mesmo código hexadecimal, mas não tem um certo ou errado, você pode optar pela qual você preferir. E é interessante você ir pegando tons da sua imagem que você vai conseguir uma combinação maneira. Dá um OK. Ou algo talvez até um pouquinho mais suave, né? Eu acho que até um pouquinho mais fraquinho, assim vai ficar interessante também, vai dar tipo uma quebrada de tons ali com o fundo, né, com o chocolate que a gente colocou na parte de baixo. Outra coisa que a gente pode fazer, eu quero deixar mais enaltecido também essa parte aqui da xícara de chocolate quente, então eu posso colocar um ajuste de degradê. E aqui no degradê vamos escolher, clica no preenchimento de degradê para você criar o seu. E aqui eu vou deixar com a última. Outra coisa que a gente pode fazer, eu quero deixar mais enaltecido também essa parte aqui da xícara de chocolate quente, então eu posso colocar um ajuste de degradê. E aqui no degradê vamos escolher, clica no preenchimento.
Features on the lunar surface yet. We just see, the topography on the limb. For the Earth glow, we're about a quarter moon, waxing quarter moon, if you will, from the Earth glow perspective, and it's just at a very, just the sight angle. I'm just not able to tell what I'm looking at yet in the Earth glow.
Understood. Thanks, Jeremy. One other question for you on the solar corona. Were you actually able to see any structure or color in the corona before most of it disappeared behind the moon?
Yeah, I didn't pick out any color, but definitely structure. There were streamers and they were not uniform at all. For me, the 5 o'clock position, there was just this constant streamer. It would change in intensity and diameter, but it was always there, and it was always at the 5 o'clock position. I only saw one plume, and it came out of basically the 3 o'clock position of the sun. That was very short-lived when I could see the plume.
Exactly what we were looking for. Thanks, Jeremy. And a heads up that we, calculated here on the ground about how long you could see the corona for, and we expect it to start to appear again in the next 11 minutes. Thanks for those amazing descriptions.
Okay, we're excited to see it all again.
Integrity Houston, we're following along as well. That was outstanding. If you haven't already, just reminding you to swap positions at the windows. And that brief LOS we had previously was due to a data rate change expected.
Okay, we copy that, Jenny.
Integrity Science, one more request for you. While it's still fresh in your mind, any annotations or sketches you want to make of what you're seeing either around the corona structures you just mentioned or even on Earthshine would be so appreciated.
Okay, Kelsey, it's going to be pretty hard to go look at a PCD right now, but we'll definitely try and annotate what we saw.
And if the annotations come in the next block where you're cleaning up your documentation, that sounds like a good plan to me.
This is Artemis Mission Control. On the bottom right corner of your screen, you can see a view of the Science Officer console here in Mission Control. And we've been hearing that communication between the Science Officer. The Orbit 1 Science Officer is Kelsey Young, and she's been asking questions to the crew, specifically CSA astronaut Jeremy Hansen, based on the observations they've been making during this eclipse period. And then in the upper left-hand corner of your screen, you can see a view of the Artemis real-time orbit website, which provides updates on the velocity and the distance from Earth and the Moon of the Orion spacecraft as it continues to make its way back to Earth. The distance from the Moon will continue to increase at this point. So right now, Orion and its crew are about 6,300 miles away from the Moon and about 251,000 miles away from the Earth.
Okay, science, we're getting set up for sunrise. The window teams are, Christina is supporting, and also Zena in window 1. Jeremy's got the long lens in window 2, and the short lens in window 2. And Reed is in window 3, and he has started recordings and is set up to see Corona.
Great sit rep, Victor. That sounds like a good config, and we're showing coronal effects start to appear on your video camera. So in the next few minutes, we should start to hear your observations.
This is Artemis Mission Control. We just heard the crew call down to the team here in Houston, reporting that they have swapped out who is in the windows for the final portion of the lunar flyby. So Christina Cook is in window 1, with Jeremy Hansen in window 2 and Reed in window 3. Reed is focusing on observing corona, which is the solar corona, which is the sun's outermost atmosphere. There is about 18 minutes remaining in the eclipse period.
Science, Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing.
Amazing. Thank you, Victor.
And just one more logistics note, we have gone as dark as we can in the cabin. We have turned the DUs all the way as dim as they can go, so you can't see anything on the screens. Every bit of light in the cabin affects the view. You're definitely seeing the brightness go closer. It's definitely brighter on the Earthshine side, and so we're expecting to see some corona here soon.
We copy all. Excited for what you see next.
I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but right off the well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet. That line of planets, there's something a moon diameter to the left, and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So. But anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window. And now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Just doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
This is just absolutely beautiful and inspiring to hear. And Victor, we suspect what you're seeing is Saturn and Mars. That reddish object is likely Mars. Good opportunity to look to the future of where we're going.
Yeah, we can absolutely see the color of Mars. That's awesome. Okay, and from this vantage point, the 4 o'clock on the Earthshine side is definitely getting brighter, still no coronal structure.
Houston copies.
And we aren't able to distinguish which Mare is, but we can clearly see Mare in the Earthshine.
We copy.
This is Artemis Mission Control in Houston, Texas.
We have not seen an impact flash in the last 5 minutes.
Sounds unlucky, but you had a pretty strong start, so we'll take it.
And actually, right after I said that, right at the South Pole, near the South Pole on the Terminator, Reed just saw one.
Amazing.
Integrity science, and as you look around our solar system neighborhood, you should see Saturn setting behind the moon right now.
We do. We've been watching it track close to the horizon, and it's right tangential to the moon at this moment.
This is Artemis Mission Control in Houston, Texas. We are currently 5 days, 2 hours, and 44 minutes into the Artemis 2 mission, and we have about 11 minutes remaining in the eclipse at the latter half of the lunar flyby that the Artemis 2 crew is experiencing on board the Orion spacecraft. We've received several different call downs from the crew and questions up from the science officer here in Mission Control. One of the things that they said that they were able to see is Mars off in the distance, and then the science team also confirmed that they should be seeing Saturn setting behind the moon. They've also acknowledged seeing several different impact flashes, and these are flashes of lights from meteorites striking the surface of the moon. They've also mentioned the solar corona, which is the sun's outermost atmosphere. Here in Mission Control Houston, the Orbit 1 and Orbit 2 teams have officially completed their handover. So the Orbit 2 team is now leading here in Mission Control, and that is being led by Flight Director Diane Daly, and the Capcom here in Mission Control will be Tess Caswell. And you can see there on your screen on the right-hand side is the Flight Director console, and Diane Daly is in the far right of that screen, and Tess Caswell, the Capcom or capsule communicator, is in the far left hand of that screen.
Yeah, the light is continuing to grow in intensity. At about the 4 o'clock position on the about the 8 o'clock position on the Earth-shine side. Saturn has set. Mars is tracking towards the moon's horizon.
Integrity science, we copy, and we're starting to see it on the vehicle stream. Looking forward to any coronal observations you can share with us.
De degrau, cores escolhem textura lá na cor do fundo, dando um OK novamente, e aqui a gente pode colocar um modo, por exemplo, de multiplicação extras, e vem padrões herdados e muito mais. Vai aparecer todas essas opções para você utilizar, de boa? Então agora sim a gente pode vir em ajustes, padrão, e aqui colocar um padrão lá no fundo. Por exemplo, vamos abrir aqui todas as opções, padrões herdados e muito mais. Deixa eu me lembrar onde tinha uns padrões que eu tô querendo. Acho que eram padrões legados, se eu não me engano. Isso, papel em tom de cinza. Aqui vai ficar alguns interessantes, ó. Acho que inclusive entre esses daqui os primeiros já ficam legais. E a gente coloca o modo de mesclagem para ele se mesclar com o fundo. Esse segundo, terceiro aqui, ó, que é o crepe, eu acho que fica bem interessante. Mas aí vai do seu gosto também. Enfim, apenas para dar uma textura lá na cor do fundo. Dando um ok novamente, e aqui a gente pode colocar um modo, por exemplo, de multiplicação, superexposição de cores, ficou muito forte, né? Multiplicação vai ficar maneiro. Então veja, ó, é um detalhezinho que ficou lá no fundo, ele ficou com uma textura bem interessante. E destacou legal, né, a parte lá do fundo. Veja que a gente já está trabalhando, conseguindo bons efeitos com o fundo. Essas opções para você utilizar. Para o centro dela. Então, ó, como que estava antes e depois. Ele acaba desfocando os fundinhos aí da sua... os cantinhos, melhor dizendo, da sua imagem. Clica o botão direito do mouse, aqui também você consegue aumentar, enfim. E a dureza do centro para fora. Ó. Então, você pode escolher aqui exatamente o ponto central que ele vai começar a destacar. E pode dar um OK. Manualmente, você... na de tons ali com o fundo, né, com o chocolate que a gente colocou na parte de baixo. Outra coisa que a gente pode fazer, eu quero deixar mais enaltecido também essa parte aqui da xícara. E aqui eu vou deixar algo mais intenso, ó, para dar um destaque aqui na parte de cima, né? Quase próximo a esse 5.4. E agora eu vou escolher o estilo radial, para deixar ele aqui do centro para fora. Então você pode escolher aqui exatamente o ponto central que ele vai começar a destacar e pode dar um OK. Manualmente você também pode criar uma nova camada e colocar uma vinheta também, ou até mesmo com um preenchimento de degradê também, se você desejar. Mas vem aqui, ó, com a ferramenta pincel, escolhe um tom também, vem em seletor de cores, escolhe um tom próximo, escolhe um mais escuro aqui, dá um OK, regula o fluxo para não deixar muito forte também, que o fluxo é a intensidade das bordas do seu pincel, pode aumentar com a tecla abre e fecha colchetes, com a tecla fecha colchetes acaba aumentando. Clica o botão direito do mouse, aqui também você consegue aumentar, enfim, e a dureza eu vou deixar em 0% para ele ficar mais suave também as bordinhas. E aqui você pode vir criar uma vinheta, como você preferir aqui na sua imagem também. Apenas para dar maior destaque para a parte do centro da nossa imagem. E inclusive vou arrastar essa vinheta para cima do splash de chocolate aqui também, ó. Tudo isso para que não fique tão nítido os cantos da nossa imagem, a gente atrai maior e melhor a atenção para o centro dela. Então, ó, como que estava antes e depois. Ele acaba desfocando os fundinhos aí da sua... os cantinhos, melhor dizendo, da sua imagem e dando total destaque para a arte do centro. Outra coisa seria legal a gente colocar até alguma leve textura na parte de baixo aqui da nossa imagem. Inclusive, tipo em cima, por exemplo, dessa parte lá do fundo, da cor. Então, selecionando o preenchimento de cores, pode vir aqui em ajustes. Ah, antes disso, vamos habilitar, porque no meu está habilitado, no seu pode ser que não esteja. Todas as formas que o Photoshop já teve antes dessas versões mais atuais. Então, você pode vir aqui, por exemplo, em janela, padrões ou formas, enfim, selecionando aqui, ó, padrões, vai habilitar aqui os padrões do Photoshop. Você pode vir nessas opções extras e vem em padrões herdados e muito mais, vai aparecer todas essas opções para você utilizar. De boa? Então agora sim a gente pode vir em ajustes, padrão, e aqui colocar um padrão lá no fundo. Por exemplo, vamos abrir aqui todas as opções, padrões herdados e muito mais. Deixa eu me lembrar onde tinha uns padrões que eu tô querendo. Acho que eram padrões legados, se eu não me engano. Isso, papel em tom de cinza. Aqui vai ficar alguns interessantes, ó. Acho que inclusive entre esses daqui os primeiros já ficam legais. E a gente coloca o modo de mesclagem para ele se mesclar com o fundo. Esse segundo, terceiro aqui, ó, que é o crepe, eu acho que fica bem interessante. Mas aí vai do seu gosto também. Enfim, apenas para dar uma textura lá na cor do fundo. Dando um OK novamente. E aqui a gente pode colocar um modo, por exemplo, de multiplicação, superexposição de cores. Ficou muito forte, né? Multiplicação vai ficar maneiro. Então veja, ó, é um detalhezinho que ficou lá no fundo. Ele ficou com uma textura bem... todas as opções. vai habilitar aqui os padrões do Photoshop. Você pode vir nessas opções extras e vem em padrões herdados e muito mais. Vai aparecer todas essas opções para você utilizar. De boa? Então agora sim a gente pode vir em ajustes, padrão. E aqui colocar um padrão.
This is Artemis Mission Control. Those.
Oh, and I think we're seeing some directionality. Some of it is going in different directions because it appears to be moving.
Inclusive vou arrastar essa vinheta para cima do splash do chocolate aqui também, ó. Tudo isso para que não fique tão nítido os cantos da nossa imagem, a gente atrai maior e melhor a atenção para o centro dela. Então, ó, como que estava antes e depois, ele acaba desfocando os fundinhos aí, também as bordinhas. E aqui você também pode criar uma nova camada e colocar uma vinheta também, ou até mesmo com um preenchimento de degradê também, se você desejar. Mas vem aqui, ó, com a ferramenta pincel, escolhe um tom também, vem em seletor de cores, escolhe um tom próximo, escolhe um mais escuro aqui, dá um OK, regula o fluxo para não deixar muito forte também, que o fluxo é a intensidade das bordas do seu pincel, pode aumentar com a tecla abre e fecha colchetes, com a tecla fecha colchetes acaba aumentando. Clica o botão direito do mouse, aqui também você consegue aumentar, enfim. E a dureza eu vou deixar em 0% para ele ficar mais suave também, as bordinhas. E aqui você pode vir criar uma vinheta, como você preferir aqui na sua imagem também. Apenas para dar maior destaque para a parte do centro da nossa imagem. E inclusive vou arrastar essa vinheta para cima do splash do chocolate aqui também, ó. Tudo isso para que não fique tão nítido os cantos da nossa imagem, a gente atrai maior e melhor a atenção para o centro dela. Então, ó, como que estava antes e depois, ele acaba desfocando os fundinhos aí da sua, os cantinhos, melhor dizendo, da sua imagem e dando total destaque para a arte do centro. Outra coisa seria legal a gente colocar até alguma leve textura na parte de baixo aqui da nossa imagem. Inclusive, tipo em cima, por exemplo, dessa parte lá do fundo, da cor. Então, selecionando o preenchimento de cores, pode vir aqui em ajustes. Ah, antes disso, vamos habilitar, porque no meu está habilitado, no seu pode ser que não esteja. Todas as formas que o Photoshop já teve antes dessas versões mais atuais. Então, você pode vir aqui, por exemplo, em janela, padrões ou formas, enfim, selecionando aqui, ó, padrões, vai habilitar aqui os padrões do Photoshop. Você pode vir nessas opções extras e vem em padrões herdados e muito mais, vai aparecer todas essas opções para você utilizar. De boa? Então agora sim a gente pode vir em ajustes, padrão. E aqui colocar um padrão lá no fundo. Por exemplo, vamos abrir aqui todas as opções, padrões herdados e muito mais. Deixa eu me lembrar onde tinha uns padrões que eu tô querendo. Acho que eram padrões legados, se eu não me engano. Isso, papel em tom de cinza. Aqui vai ficar alguns interessantes, ó. Acho que inclusive entre esses daqui os primeiros já ficam legais. E a gente coloca o modo de mesclagem para mais. Selecionando aqui, ó, padrões, vai habilitar fundo da cor. Então, selecionando preenchimento de cores, pode vir aqui em ajustes. Ah, antes disso, vamos habilitar, porque no meu está habilitado, no seu pode ser que não esteja. Todas as formas que o Photoshop já teve antes dessas versões mais atuais. Então, você pode vir aqui, por exemplo, em janela, padrões ou formas, enfim, selecionando aqui, ó, padrões, vai habilitar
This is Artemis Mission Control. There on your screen, you can see a live look inside of the SIR, or the Science Evaluation Room, here in Mission Control Houston, just down the hallway from the Artemis Flight Control Room.
Integrity Houston, back with you after a data rate change. Regarding the SAW-3 camera T low caution, no action for you. It just got a little cool during the eclipse.
Okay, we copy, and if you didn't copy my request for the mission summary to add about 20 new superlatives to help my vocabulary, I would appreciate it.
We copied it fantastically.
And Integrity Science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And Science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So you all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reed. Thanks so much.
And this is Artemis Mission Control. The lunar flyby observation period is starting to come to a close following that eclipse. And there on your screen you can see a look into the Science Evaluation Room, or the SIR, which is embedded within Mission Control to provide science input. And they provided that input throughout the live flyby operations today. They also have a back room called the Science Mission Operations Room that processes data, evaluates imagery, and supports rapid analysis. And then, of course, we have the science officer on console here in the Artemis Flight Control Room, which you can see a view there on the bottom right-hand corner of your screen. The science officer throughout the flyby operations today has been Kelsey Young, who is the Artemis Science Flight Operations Lead. And then to her left is Angela Garcia, who will be the science officer taking over for Orbit 2. And for the past 7 hours or so, the crew has been going through their lunar flyby observation period. And now they will wrap up that period and complete some final tasks and begin downlinking some of the amazing imagery that they've captured throughout the day, as well as some of the observations that they've recorded. And now on your screen, you're seeing a live look from the Orion spacecraft from those solar array wing cameras. The solar eclipse period ended just a few minutes ago, and during this eclipse, towards the end of the flyby window, it lasted about an hour, and it was when the sun was hidden from view behind the opposite side of the moon from the perspective of the Orion spacecraft and its crew. And during that time, the crew saw a mostly dark moon, and they used the opportunity to analyze the solar corona, which is the sun's outermost atmosphere, while it was visible. And then once the sun was completely out of view behind the moon, the crew looked for impact flashes, which they reported seeing multiple impact flashes, and those are flashes of light from meteoroids striking the surface of the moon. They also looked for dust lofting above the limb or the edge of the moon, along with some deep space targets, including planets, and they noticed Mars off to the distance, and we also saw Venus on one of the solar array wing cameras early on in the eclipse period. The crew also looked at parts of the moon illuminated by Earthshine, which is the sunlight reflected from the Earth when they come around toward the moon's near side at the very end of that flyby window.
Integrity Houston, understand that you are still reflecting upon and consolidating your lunar observations. At your convenience, I have 2 items related to the upcoming VIP event.
Go ahead.
All right, first we wanted to let you know that the message for that upcoming event is on board for review at your convenience. That's message 3.06.04. The second item is that we've seen a couple of video blips in previous events. So during the HDPAO setup activity, we're wondering if Jeremy could please confirm for us that the TS rate is set to 1300 when you get to step 10.
Okay, Jenny. Yeah, we're pretty sure we've been in 1300 for all the PAO events. We've been tracking that when we swap between the HHP and the D5.
We copy, Jeremy. Thanks. And for the record, the phenomenal Jenny has gone on to her next appointment of the day, and you've now got Tess with you.
I'm sorry, Tess. Great to have you on board, Integrity.
No worries. Happy to be here.
This is Artemis Mission Control. We heard some communication there between the Capcom or capsule communicator here in Mission Control, which for Orbit 2 is Tess Caswell, and the CSA or Canadian Space Agency astronaut on board the Orion spacecraft, Jeremy Hansen. They were discussing an upcoming public affairs event.
And Integrity, 3-minute warning for the maneuver back to bias tail to sun.
The crew on board the Orion spacecraft recently completed their lunar observation period. It was an approximately 7-hour period of time in which they were focused on several different targets identified by the science team here on the ground that they studied and prepared for ahead of time. And then they also were referencing a lunar targeting package that was uplinked about a day ago with those final targets. Now they are completing some post-lunar flyby activities, so they're working to clean up their observations that they've made and also working to downlink some of the photos that they've taken throughout the day. The science team here on the ground will then work to get as much data as they can overnight, and then there will be a post-flyby conference tomorrow after the crew wakes up. And that's not a debrief, but a science data collection to capture their nuanced experience while they're still in the field and the experience is still fresh. And then, of course, there will also be a public affairs downlink event later in the day. Now that once the post-lunar flyby activities are complete. And then after that, the crew will go into some of their final activities for the day. They will have a private medical conference or PMC with the medical teams here on the ground. These are regular conferences that they have at the end of every day, and then there's also a flight director conference that they will have before they go into their pre-sleep period, during which they can complete hygiene activities and they will have the chance to eat their dinner and complete any other final personal activities for the day before they head into their sleep period.
ready for us to start the stream a bit early and to test scene and voice.
Checking. And integrity, affirm. We are go to start the stream.
Okay, Houston, the stream has started. We checked the TS rates 1300 and audio is true. So I will give you a voice check now on the mic.
We copy good settings and we've got a good view.
In test, I sent an audio check down on the handheld mic. Did you get it?
Sorry for the delay, Jeremy. We were talking that a bit, but it was a bit broken, so please repeat for us. Integrity, Houston, we like the scene. At your convenience, we'll take a 10 count with Jeremy in frame.
Okay, copy that. Give us 2 minutes and or 1 minute and we'll do that.
Copy. Great voice check and good words. We like the scene. in Integrity Houston, we are seeing a black cable going right through the middle of the scene. At your convenience, if you would please move that, PAO would appreciate it.
This is Artemis Mission Control. We're currently 5 days, 3 hours, and 21 minutes into the Artemis 2 mission following a liftoff from NASA's Kennedy Space Center in Florida on Wednesday, April 1st. The crew on board the Orion spacecraft is currently wrapping up their lunar flyby cleanup activities. They're making final...
Houston Integrity, high priority PAO images from the eclipse are on PCD-1 in a so-named folder.
We copy, Christina. Thanks.
And NASA astronaut Christina Cook there calling down to the ground regarding some public affairs imagery that was captured during the lunar flyby activities. She referenced a PCD, that is in reference to their portable computing devices, which are basically tablets that they're able to transfer files and also follow along on processes and procedures and their timelines for the day. No. This is Artemis Mission Control in Houston, Texas. Currently on console here in Mission Control is the Orbit 2 team of flight controllers being led by Flight Director Diane Daly and the Capcom or Capsule Communicator, who serves as the single voice link up to the crew, is Tess Caswell. The crew on board the Orion spacecraft recently wrapped up their lunar flyby observation period, and now they are completing some cleanup activities and transferring some data and files down to the ground following that lunar flyby. Many of these files will be analyzed by the science team overnight in advance of a post-lunar flyby conference tomorrow once the crew wakes up. The crew is also preparing for an upcoming public affairs downlink event. And then following that downlink, they will have a few final activities for the day, including a private medical conference with their team here on the ground. These are standard conferences that happen at the end of every day, and they'll also have a private conference with the flight director here in Mission Control to go over the vehicle status and any other questions or concerns they may have for the remainder of their flight. We are currently in flight day 6, and we have a splashdown expected on Friday, April 10th. That splashdown expected in about 3 days, 21 hours, and 49 minutes from now. During the lunar flyby, and as part of Artemis 2, it marked the first time in more than 50 years that humans were able to observe the moon directly and provided a critical opportunity to practice how lunar science will be conducted during future Artemis missions. The moon preserves a near-continuous record of solar system history that has been erased on Earth, and with no atmosphere, weather, or plate tectonics, the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. Studying the moon helps scientists understand how planets formed and evolved, how the moon influenced Earth's history, and how the early sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. The science on Artemis is designed around questions best answered by humans working alongside robotic systems, combining decades of robotic lunar data with real-time human judgment, context, and adaptability. Currently on your screen, you're seeing a look at the Artemis real-time orbit website. You can access this website at any time throughout the mission at nasa.gov/trackartemis. It provides updates on the velocity as well as the distance from Earth and the distance from the moon of the Orion spacecraft and its crew. The crew currently on board the Orion spacecraft includes NASA astronaut Reed Wiseman, who is the commander for the mission, NASA astronaut Victor Glover, who is the pilot, alongside the 2 mission specialists, who are Christina Cook and Jeremy Hansen of the Canadian Space Agency. Currently, the Orion spacecraft is about 250,000 miles away from the Earth, and that distance now will continue to close down ahead of that splashdown on April 10th. And they are now about 8,100 miles away from the moon, and that distance will continue to increase as they are now in the return leg of their journey.
ahead, Integrity.
Hey, Jess, great to talk to you. Any chance we could drop the fan speed down for this PAO event?
We will put that in work. Great to be talking to you, too.
This is Artemis Mission Control in Houston, Texas. We're currently 5 days, 3 hours, and 37 minutes into the Artemis 2 mission. The crew on board the Orion spacecraft has recently concluded their lunar observation period during the lunar flyby. As part of that lunar flyby, the Orion spacecraft and its crew made the closest approach to the moon at a distance of 4,067 miles away from the surface at approximately 6 p.m. Central Time, 7 p.m. Eastern Time. Now, although the Artemis 2 mission is a new opportunity to study the moon, teams are also conducting other scientific experiments, including on the crew themselves. Here's a little bit more about the science of the mission.
Artemis 2 is our return of humans to the moon, flying around the moon on board Orion. But along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field. Here in low Earth orbit, the crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis 1, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that it's going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system, so what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth?
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
How Getting human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the Science Officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis 2 will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox-sized spacecraft of their own. They're each provided by another country, one of our partners. As they conduct their research, they'll complement what we are doing at the moon with Orion.
It is so incredibly exciting to be a part of this mission.
It has been, really one of the privileges of a lifetime.
I can see the work I'm doing benefit crew members right now and benefit the crew members in the future. So it's incredibly exciting and it's very rewarding.
As this rocket launches humanity off of the Earth, we'll be setting the stage through our science to prepare humanity to leave Earth and explore the solar system.
And as part of that, we are going to inhibit cabin leak detection. The edge key manual response is still available. Copy, thumbs up.
This is Artemis Mission Control. Again, we're hearing some communication between the ground here and the Artemis Flight Control Room in Houston, Texas, specifically the Capcom or Capsule Communicator, who for Orbit 2 is Tess Caswell, and the crew on board the Orion spacecraft, that spacecraft named Integrity by its crew. They are preparing for an upcoming public affairs event, so they are discussing the camera views, which we will see here shortly. There on your screen on the left-hand side, you can see the Artemis Real-Time Orbit website, or ARO. The Artemis Real-Time Orbit website there on the left-hand side of your screen provides updates on the velocity of the Orion spacecraft during its journey around the moon. Following a lunar flyby earlier today, which concluded about an hour ago, the crew has been conducting some cleanup tasks, so they've been transferring some of their documentation, their photos and data that they captured during the flyby to the ground to be evaluated by the science team, and of course some of that imagery will also be evaluated by the public affairs team here at NASA and then shared with the world once it's available. The crew will also have a post-lunar flyby conference with the science team tomorrow following their sleep period to go over some of their observations while it's still fresh and at the top of their mind. On the bottom right-hand corner of your screen, you can see a look into the Artemis Flight Control Room here in Mission Control Houston, specifically the Flight Director Console and the Capcom or Capsule Communicator Console. The flight director currently on console for Orbit 2 is Diane Daly, and throughout the Artemis 2 mission, there are 3 shifts or orbits of flight controllers who provide 24/7 coverage and support to the Artemis 2 crew and the Orion spacecraft and its systems during its journey around the moon. We are expecting a splashdown on Friday, April 10th. That splashdown will take place in about 3 days, 21 hours, and 33 minutes.
During the lunar flyby that took place earlier today, Orion, again that spacecraft named Integrity by its crew, passed approximately 4,000 to 6,000 miles from the moon and provided the crew with a full disk view of the lunar surface. And from that higher vantage point, much farther than Apollo's lunar orbits on average, the astronauts were able to observe both poles and large-scale geological features in a single view. And there on your screen, you're currently seeing a live look inside the cabin of the Orion spacecraft.
Integrity Houston, we are 3 minutes out from an on-time start, and we have adjusted the fan speed. We'll take a thumbs up if you're happy with it. Copy, thumbs up. Superlative thumbs up.
And there on your screen, you can see all of the Artemis II crew members. CSA astronaut Jeremy Hansen just floated out of view behind the camera, but you can still see NASA astronaut Reed Wiseman, NASA astronaut Christina Cook, and NASA astronaut Victor Glover as they prepare for an upcoming Public Affairs Downlink event, which is scheduled to take place in just a couple minutes from now. And there, floating back onto the screen, is CSA or Canadian Space Agency astronaut Jeremy Hansen. He is making himself comfy on some of the OX or Orion Crew Survival System suits that have been stowed for the outbound and now return journey. Shortly after the completion of these couple of public affairs downlink events, the crew will begin winding down for their day, and they will have the opportunity to eat dinner. Some of the items on their menu today for dinner include chicken with corn and black beans, sweet and sour pork, rice pilaf, spicy green beans, citrus fruit salad, and maple cream cookies. All of the And now we will go ahead and stand by for that public affairs event beginning in just about a minute.
Integrity Houston, no action for the DU-1. Caution, we're taking a look. Integrity, this is Houston. Are you ready for the event?
Hello, Houston. Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, comm check.
Administrator Isaacman, we've got you loud and clear, sir. How us?
I've got you loud and clear. Artemis II crew, we have a very special guest who wanted to be the first person to greet you after your return from the far side of the moon. Reed, Victor, Christina, and Jeremy, it's my honor to introduce the President of the United States of America, President Donald J. Trump. Over to you, sir.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but this is there's nothing like what you're doing, circling around the moon for the first time in more than a half a century. and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reed Weissman, Pilot Victor Glover, Mission Specialist Christina Koch, and Jeremy Hansen. And I also want to thank the entire amazing team at NASA, headed by Jared, who's a very special guy, by the way, and you all made this day possible, and you've really inspired the entire world. Really, everybody's watching. They find it incredible. I just watched you go to the back of the moon, and people haven't been there in a long time, we can say, but it's going to be more and more prevalent because we're going to be doing a lot of traveling, and then you're going to ultimately do the whole big trip to Mars, and that's going to be very exciting. So you look at, we had no astronaut has been to the moon since the days of Apollo program. The Apollo program was also very special, but that was 50 years ago. And at long last, America is back, and America is back in many ways stronger than ever before. We're the hottest country anywhere in the world. The Artemis crew flew in the most powerful rocket NASA has ever made, ever launched, traveled over 250,000 miles, broke the distance record set by the legendary Apollo 13. And America is a frontier nation, and the 4 brave astronauts of Artemis II are a modern day, you really are modern day pioneers, all of you. And one of them happens to be a neighbor. You know who that is, right? You have a special person over there, a neighbor, and we like our neighbor. Your mission paves the way for America's return to the lunar surface very soon. We're going all out. We're doing everything we can, and it's headed up by Jared. We'll plant our flag once again, and this time we won't just leave footprints. We'll establish a permanent presence on the moon, and we'll push on to Mars. That'll be very exciting. I'm waiting for that so much. I'd love to be here, but maybe we won't quite make it in terms of timing, but we will be up in the moon, and that's going to happen soon. So America will be second to none in space and everything else that we're doing, and we will continue to lead the whole thing into the stars, this incredible journey into the stars. So I just wanted, it's an honor to speak to you, and I wanted to congratulate each and every one of you. And tell me, what is the most unforgettable part of this really historic day? The whole world is watching and listening. Please tell me.
President, this call is certainly special to all of us, and we really have a lot of faith in our administrator, Jared Isaacman, who is with you. We appreciate his leadership in NASA and in the international community. We are doing great things, and we are proud to be a part of it. I have to tell you, as we came around the near side of the moon, seeing all the sights that we've seen from Earth for all of our lives, but we're seeing them from a different perspective, and then we started to get a glimpse of the and we saw sites, oriental sites that no human has ever seen before, not even in Apollo, and that was amazing for us. And then the surprise of the day, we just came out of an eclipse where the sun, moon, and the entire dark moon about that big right out the window that we were watching. We could see the corona of the sun, and then we could see the planet train line up, and at Mars, and all of us commented how excited we are to watch this nation and this planet become a 2-planet species.
That is fantastic. You know, I had a decision to make in my first term, and the decision is, what are we going to do at NASA? Are we going to have it be revived, or are we going to close it down? And I had very little hesitation, and it's really great to have somebody like Jared involved, because he really makes it much easier for me. But it was not even a question in my own mind. We've spent what we had to do, and then of course we have Space Force, and Space Force is very much related to what you're doing, and that was my baby. That was a very important one, and it'll turn out to be truly one of the most important, I believe, decisions I've ever made. So we're very proud of Space Force, and we're very proud of all of you. Does anybody else have anything to say? A lot of people listening.
Mr. President, To be here with you speaking about our incredible day today. I think one of the biggest highlights was coming back from the far side of the moon and having the first glimpses of planet Earth again after being out of communication for about 45 minutes. It really just reminds you what a special place we have and how important it is for our nation to lead and not follow in exploring deep space.
I'd like to ask, what was your feeling when you had no communication, zero communication, all of a sudden it was cut off by, obviously, your very special location. What was your feeling when you had no communication? A little bit different, perhaps.
Yes, Mr. President, it was I said a little prayer, but then I had to keep rolling. I was actually recording scientific observations of the far side of the moon. You know, that is actually the time when we were the farthest and the closest to the moon. And so we were really able to make some of our most detailed observations of the far side of the moon up close. And so we were busy up here working really hard. And I must say, it was actually quite nice.
Did you see a difference, a big difference between the far side of the moon and the near side of the moon? Was there a difference in feel or difference in look? What did you see?
Well, Mr. President, we certainly did, and our science team really set us up well to understand what they thought we might see. And the gravitational pull of the Earth has had a profound effect on the near side of the moon, changing all those dark mares, those dark patches of the moon you see from Earth. It's very different on the far side. While you see some small patches of those mare in deep craters, it's very much absent on that side, so that's really neat. And while I have the microphone, sir, I just want to thank you on behalf of Canada. The space leadership you spoke of from America truly is extraordinary. I've said this many times before. A nation that leads like that and creates and sets big goals for humanity that brings other countries along with it is truly incredible. And I know that's a very intentional, not a necessary decision, intentional decision to lead by example and to allow other countries like Canada to share our gifts and help you achieve these mutually beneficial goals, like establishing a presence on the moon and eventually going to Mars. And Canadians are so proud to be a part of this program.
Well, I have to say I spoke to a very special person, Wayne Gretzky, who I think you know, the great one. And I spoke to your Prime Minister and many other friends I have in Canada. They are so proud of you. And you have a lot of courage. I'm not sure if they'd want to do that. I'm not even sure if the great one would want to do that, to be honest with you. But you have a lot of courage doing what you're doing, a lot of bravery and a lot of genius. But they're very, very proud of you.
え、100円拾った？君、いくつ？
え？18歳ですけど。
Administrator Alex, I'm going to just get a quick comm check, make sure you guys are still on the line and we didn't have a handover.
I am. Yes, I am.
And integrity, and back over to you, Mr. President.
Yeah, I think we might have gotten cut off. It is a long distance. It's a long ways. The reception's been great. There's a little bit of about a 9-second delay, but no, I just had a statement for, I don't know what you heard, but I was just saying they're very proud of your brilliant person from Canada on the ship. And Wayne Gretzky is a great friend of mine, and he's very proud of him. And the Prime Minister I spoke to, they're very, very honored that you have a courageous person from Canada. You have a lot of courageous people from Canada, so it was very nice. I'm not sure if you heard me say that, but it was very nice.
Yes, Mr. President, we heard that, and we do love our Jeremy Hansen. We love all our Canadian astronauts, Jenny Gibbons, Josh Kutrick. They're just great people, and they're such a welcome addition to our Corps.
Great. Well, I really look forward to, when we can, I look forward to seeing you in the Oval Office. I'll ask Jared to bring you over, and I'll ask for your autograph, because I don't really ask for autographs much, but you deserve that. You really are something. Everybody's talking about this. And I look forward to having you in the Oval Office at the White House, and we will celebrate your incredible achievements and triumphs. This is big. This is really big stuff. The whole world is talking about it. And if you have the time, I will certainly find the time. I've been pretty busy also, as you know, but I will absolutely find the time, and we'll get together, and I'm going to be giving you a big salute on behalf of the American people and beyond that.
Thank you for that, Mr. President, and when you want us, we will be there. And thank you for your leadership. Thank you to Jared for his leadership. Really, thank you for taking the time out today to visit NASA. It's really special for us, but it's really special for the team on the ground. A whole team of people all around the world pulled this off, and we just want to say thank you to all of you for this. It is the thrill and honor of a lifetime to have been on this journey. Today was amazing, but this 3-year journey has been amazing, and it was made possible by the American people and the Canadian people, and we're so grateful to you all. Thank you very much.
Well, thank you very much. And Jared, congratulations. We'll see you soon. And I know that you have Mars very much in your mind, so we'll start thinking about that pretty soon, I think. And thank you. Congratulations to everybody. I'll see you at the Oval Office.
Thank you for your time, Mr. President. It's been an honor.
Thank you very much. Bye.
Bye.
Integrity. This is Houston ACR. That concludes the event.
Because
Thank you.
I don't really ask for autographs much, but you deserve that. You really are something.
Thank you to all
Everybody's
participants.
Talking about this.
Integrity. We are now resuming operational audio communication.
But you deserve that. You really are something.
Thank you to all participants.
About this.
Integrity. We are now resuming operational audio communication.
But you deserve that. You really are something.
Thank you to all participants.
About this.
Integrity. We are now resuming operational audio communication.
But you deserve that. You really are something.
Thank you to all participants. Integrity, we are audio communication.
But you deserve that. You really are something.
Thank you to all participants. Integrity, Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event on time at Houston. Great job on the event. Just a heads up, we are on track to start the next event.